Okay, we're back for another week. This week is shorter, right? You have Monday, it was a holiday. So we're going to, and we are into a new unit. So we're starting linear relations. We are gonna do just one lesson this week, okay? So this is an opportunity for students that need to catch up and get totally caught up on the equations unit that we just wrapped up that last week. This would be the week to send in the homework that you haven't completed. If there's any outstanding quizzes, make sure you complete those. For students that are on top of everything, this will just feel like a lighter week for you. Okay, so there won't be a quiz at the end of this week. There'll just be the one lesson as well. Okay, so something that I've been missing, and I'm sure you have too, is our math talks that we used to do, our number talks. So I threw one out up here. And I thought, well, for those students that also miss it, you could copy these down and see how many that you could solve, okay? Much like we would do in the classroom. So press pause for those that are trying it, and I'm just going to talk about it now. So of course in the classroom I'd be getting your feedback. It's a lot more fun to do that. So I'll just have to throw up the answers myself. So I'll start with the easiest one, right here, 8 minus 6, 2. Okay. 6 minus 8, probably many of you got that, right? We're subtracting a bigger number, so we're into the negative, so it's negative 2. Now you might notice similarities here, right? The 6 is positive and the 8 is negative, so 6 minus 8, that's the exact same as negative 8 plus 6, right? So if you set up a number line, and let's say you start at negative 8, when you're adding 6, you're moving towards the positive end by 6. So negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, 1, 2, 3, 4, 5, 6. So negative 2. Okay, so that one's negative 2. So recall for these ones, we don't like double signs. Okay, so you would replace two signs side by side. There's no number in between. So that's a double sign. You would replace two negatives, get replaced by one sign, and it's a plus sign, okay? So this question becomes negative 8 plus 6, exact same as this one, so negative 2. Okay, this one, we're starting at negative 8 on the number line, but we're subtracting 6, so we're moving towards the negatives, okay? So if you went over 6, you would arrive at negative 14. Okay, just throw another little number talk in there. Okay, so like I said, we're starting with the linear relations unit. We'll just start here. So this is a little bit different in terms of making videos. Basically, this is a sheet that I go through with you in the classroom, and we kind of work on together. So at least for the first example, so there's 3. You will open it up as a PDF file at home. If you have it in front of you while I'm doing this, that would be the best. And I know some of you can't print them out, so you'll just, if you can have it open on another screen, or I've written out as much as I possibly can, so that you can kind of see what would be on the sheet, and then afterwards you'll just have to take this information. You don't have to copy, I don't need all of the tables and all of the questions rewritten out. It would be fine for when you're submitting just to write question 1 and answers, okay? Okay, so our new unit is linear relations. We're gonna start today with first differences, okay? So that's this week's lesson. Next week I have 2 lessons. We're gonna do rate of change. It's a bigger topic, so we're gonna cover it in 2 lessons. And then we'll get into direct and partial variations, and then we're making equations for linear relations. Okay, this will probably take us to close to the end of the course. Okay, so let's get started. So yeah, so the sheet that you have, there's 3 problems. This is A of the problems, okay? So what it says is, Jody works at a factory, she's building square tiles. There's a bit more detail on your sheet, but that's the gist of it. She's building square, that's kind of key, square tiles. So calculate the perimeter as the side length goes up. So we're just going to fill in this table. Okay, so if the side length is 1 centimeter all the way across, recall perimeter is the distance around. So your perimeter is just going to be 4 centimeters. okay? That would be for that one. And then let's say our tile's a little bit bigger, so, and they're all square, right? So now it's 2 all the way around, 2, 4, 6, 8. So now our perimeter is going to be 8. If it was 3, 4 sides, right? So we could just times this by 4. So 3 times 4, that's 12. 4 times 4, that's 16. And 5 times 4 sides is 20. So there, that's what our perimeter looks like as the side length goes up by a centimeter. Okay, so today's lesson is all about calculating first differences. So the way you calculate first differences, and you will do this again next year in grade 10, okay, but you'll also calculate second differences. So the way that you calculate your first differences is you're going to take the number after, okay? So I would take, here's my first kind of number, and here's my second number. I take the second number and I subtract the first, okay? So this would be 8 minus 4. So it's 4, okay? Then I take the one after it and I subtract the one before it. So this is 12 minus 8. So it's also 4. Take the one before, subtract the one after, 16 minus 12, 4. And 20 minus 16 is 4. Okay, we'll go back to it, but just note for now that all the first differences are the same and all the first differences are positive. Okay, so that's the first part on the handout. Okay, so the sheet then goes on and asks a few questions. Okay, so first question, it says, describe what happens to the perimeter of each tile as the side length increases by 1 centimeter. Okay, so you noticed, I'm sure, from here, that as this is going up by 1 centimeter, your perimeter is going up by 4 centimeters, okay? So I would say here, to make a full sentence, as the side length increases by 1 centimeter, the perimeter increases by 4 centimeters. Okay, that's it for that one. Okay, next is this to construct a graph, okay? Perimeter versus side length. It asks you, what's the independent variable? So, this kind of goes back. We've gone over some graphing. We're kind of going back to it a bit. So we've got 2 variables. One variable is the side length of the tiles, and the other is the perimeter. So you ask yourself, what's dependent on the other, right? Well, the side length is the one that they're kind of in control of at this factory, right? So they're adjusting the side length, and the perimeter is going to be affected by whatever side length that they choose. Okay, so this would make this one the independent, and this is the dependent. Okay, so remember that statement when we were going over our graphing is depends on. Okay, so whichever one depends on the other, that will be the dependent variable. Okay, so our dependent variable is the perimeter. And it's often easiest to figure out which the dependent variable is. And then from there, obviously the other one is the independent. So side length is our independent. Okay, describe the relationship. Well, we'll describe the relationship after we graph this. Okay, so as we're going to graph, recall independent variable goes on the bottom. So I'm going to put side length down here. Okay, and if you're doing this at home and you haven't been able, you can't print it out, you can just do this on paper, on lined paper, and that would be fine. Okay, just try and use a ruler or some kind of straight edge, but it doesn't need to be perfect. And that's the perimeter. Okay, so what we need to know now is our scales for each one. Okay, remember when you're setting a scale, I'm going to have to go up by the same number okay, each time. But my scale for the side length does not need to be the same scale as what I do for the perimeter. Okay, so I don't have to just have the same scale, but I can't change my scale within for a certain variable. So let's look here. Our side length needs to go from 0, let's say 0 to 5, okay? Or actually I always started at 1 because you're not going to have a tile with 0. So I would probably start right at 1. So we're going to go from 1 to 5, and our perimeter needs to go from 4 to 20. So let's say we do, yeah, let's do 1. We're going to start 1. 1, 2, 3, 4, 5. That's as far as we needed to go. Okay, and our perimeter